All right, so here we want to find the limit as x approaches 0 for cosine of 1 over x, of course, if it exists. Now, for this one here, we do need to think a little bit deeper about cosine. What do we know about cosine? Well, we know that a cosine is going to have an output between -1 and +1. So let's think about that. When is cosine going to give us an output of -1? When is it going to give us an output of +1? And so on. Let's think about that for a second. So just thinking about when we get a +1, when we get a -1. Well, we know cosine of 0 gives us a +1. And then every 2 pi after that, we're going to again get a +1. So 0, 2 pi, 4 pi, 6 pi, and so on. -1, we're going to get a -1 out at pi, and then every 2 pi after that. So 3 pi, 5 pi, 7 pi, of course, and just continue from there. Of course, it would be the same in the negative direction. So on. Let's think about when we could possibly have, or kind of what we're going to get out here. Cosine of 1 over x. Well, if x ends up being the reciprocal of 2 pi, 4 pi, 6 pi, or so on, then we'd be taking cosine of 2 pi, 4 pi, or 6 pi. Because 1 over the reciprocal, of course, would just be that value. And it's going to continue on forever. So there's always a smaller number. Think about that, because now I'm thinking about the reciprocals, what x would have to be in this situation in order to get us cosine of 2 pi. That'd be like the cosine of 1 over 2 pi. And so as we go down this list, we're actually getting smaller and smaller numbers. We're actually approaching 0. It's like 1 over 2 pi, 1 over 4 pi, 1 over 6 pi. We're getting closer and closer to 0. And as we approach 0 here, as we approach 0 in this direction, we get closer and closer. So here, at 1 over 6 pi, I'm getting an output of 1. Well, very similar, 1 over pi, 1 over 3 pi, 1 over 5 pi, 1 over 7 pi, these are giving us outputs of -1. And so there's always a smaller number that can give us +1. There's always a smaller number that can give us -1 as we get closer and closer to 0. So think about this. Way down the line here at 101 pi, that's 1 over 101 pi. That's a pretty small number. Up here, we could get even smaller, 1 over 102 pi. And you know what? Just when you think this one's so small and is giving you an output of -1, this one's even smaller and it gives you an output of +1. So no matter how close we get to 0, it's going between these two values, -1 and +1. We call this an oscillation. It is oscillating between these two values over and over and over again as we get closer and closer to 0. Let's see what the graph looks like. There's cosine of 1 over x. As we get closer to 0 here, it's bouncing between these two values. Getting a negative, we're getting closer and closer to 0, but we're getting a -1. We're also getting a +1, back and forth, back and forth. And that's happening from both directions, of course, because we could go here in the negative direction and see things like -1 over pi and -1 over 2 pi and so on. Of course, this is happening the same thing in the negative direction because cosine is an even function. It's going to be symmetric across that y-axis. So this is not approaching any value. As we come in from the right side or the left side, it's not approaching anything. It is oscillating between these values. And so for that reason, we say this limit, the limit does not exist. crazy one.